Okay, in example 3.3, we're going to find the critical numbers of f of x equals x to the fourth minus x squared, and then the intervals on which f of x is increasing or decreasing. That's a typo. Okay, so the first thing you want to do is take the derivative, df dx, or f prime of x, and that'll be 4x cubed minus 2x. And then you want to set that equal to 0 and solve for x. Okay, and so there, I can factor out a 2x, and so I get 2x squared minus 1, or 2x times 2x squared minus 1 equals 0. And so there are two ways this could equal 0. Either 0 could equal 2x, or 0 could equal 2x squared minus 1. In the first case, you get that x equals 0. And in the second case, you get that 1 equals 2x squared, or x equals plus or minus the square root of 1/2. Okay, so we get three critical points. The critical values are where the derivative is equal to 0 or undefined, and since this is a polynomial, the derivative will never be undefined, so you're only looking for when the derivative is equal to 0. Okay, so this is the negative square root of 1/2 would be over here. Positive square root of 1/2 would be kind of right there. And then the 0 is right there, obviously. So now we have our critical values. And we need to check points in between those critical values to see if the function's increasing or decreasing, or to see if the derivative is positive or negative. And so I could plug in like f prime of 0 f prime of 0 we already know is 0. F prime of, let's say, -1. You'll get 4 times -1 cubed minus 2 times -1, which is 4 plus 2. No, -4 plus 2, which is -2, so it's less than 0. So we know the function is decreasing over here. If you plug in, let's say, -1/2, then you get 4 times -1/2 cubed minus 2 times -1/2, which is 4 times -1/8, or -1/2, and then plus 1. So that's positive 1/2, which is greater than 0. So that says that the function is increasing from negative square root of 1/2 to 0. And let's see, if I plug in f of positive 1/2, then I get 4 times 1/2 minus 2 times 1/2 will give me 4 times 1/2 cubed, sorry. So that's 4 times 1/8, which is 1/2. So I get 1/2 minus 1, which is -1/2, which is less than 0. So again, it's decreasing from 0 to square root of 1/2. And then finally, if I plug in f prime of 1, then I will get 4 times 1 minus 2 times 1, which is 2. That's greater than 0. So again, it's increasing on that last interval. So just to summarize, we have the function is decreasing on the interval from -infinity to negative square root of 1/2, union 0 to the square root of 1/2. And it's increasing from negative the square root of 1/2 to 0, union the square root of 1/2 to infinity.